Good morning, everyone. Welcome to the EasyPower Tuesday webinar series. My name is Jim Chastain, and today's topic is something that has a little bit of history behind it. While we're waiting for folks to settle in, I was going to kind of review it briefly. In 2002, when the original 1584 model was released, arc flash was an unknown quantity, and in the audience were many deniers, avoiders, people that were puzzled trying to understand what the arc flash hazard really meant to their overall safety. And so 1584 2002 version was the first attempt to characterize the thermal and electrical properties of the plasma itself and introduce the fact that the arcing current was actually less than the bolted fault, and it was something that system designers may not have taken into account when the original system was designed on any given facility. And so we struggled trying to get the word out, and most of the time was spent trying to define arc flash as a recognized safety hazard so it would fall under the purview of the general duty clause of OSHA. There was a modification in the 2004 range that expanded some of the details of the model, but it wasn't until 2013 that an addendum or a new standard 1584.1 was released, and this was viewed as an application note and expanded upon the parameters and the procedures that it took to implement the model. And so it helped a little bit, and in some regards it obscured some of the original intent, which was to increase the safety, because it put a strain or a burden in the cost of doing this safety improvement on different parts of the organization and the industry organization. So that brings us to 2022, when we have an updated version of 1584. And it was committed to by the 1584 committee as a refinement or a chance to align the 1584.1 document with the new model 2018. And so that's what I was anticipating when we first titled this particular presentation. And as I look at it now, what it is and why it's relevant to me is an entire overreach on my part, because the relevancy, I think, is going to be based on individual positioning in the market of the people that are using or implementing 1584. So with that in mind, let's jump into the discussion. So I'm handling this more as a book report, not as a thumbs up or thumbs down on what should or should not be done. So as we are in the habit of doing, we'd like to start with a couple poll questions. And the first is, having used 1584-2002 in the past, are you now comfortable using 1584-2018 for studies? This is another point of concern that some people have based upon their understanding of the model and how it applies to their particular system, which is the way it should be. There should be some intelligence brought into the discussion, and that's the reason we want people on the ground doing the work, understanding the system, to be the ones making these decisions. Okay, looks like we got a quorum. Here's how people have weighed in on this question. Very interesting. So it looks like we have a majority, at least, utilizing 1584-2018. Then the next question is, which correction factors of the 1584-2018 model do you usually update? And this is one of the quandaries that we have as users of the model at any given time. And I'm really interested in seeing what these results are. So, okay, looks like we have the quorum. Here's how folks have weighed in on this. Again, very interesting results. And I'm not sure what I expected, but this, I think, would meet kind of my distribution of the answers if I were to answer the question. And then the final poll question is, do you utilize the 2-second rules as it's described? I use the term advisedly, but as it's described in the 1584 model. Again, I expect kind of a wide distribution of answers here too. I very frequently get copies of people's one-line or their EasyPower model where they've applied the 2-second rule across all voltage ranges. And I personally would do that only advisedly, but we can talk more about that a little bit. They're actually kind of fun for me because I seldom am able to get this kind of feedback on a one-to-one basis. Okay, here's how folks have weighed in. A little surprised, and we can go into that later. Appreciate the contribution and the participation. Let's kind of get into the rest of my discussion here. So for those of you that haven't seen the document, this is what the front cover looks like. And the title is the same as it was in 2013, except it's as a new update down here on the corner, reflecting that it was released in 2022. What's striking and what jumps out at you as soon as you start to read the document is what it does not address. And on this list, I put asterisks because these are topics that were fairly well discussed in the original 1584.1. And so specifically, there's no PPE recommendations for arc flash protection in the current update. There's no recommendations for label content. Again, this is all deferred to NFPA 70E and to the documents 1584 where there is content. There's a specific exclusion of mitigation recommendations, which was a significant portion of the report recommended in the original 1584.1. And aside from just providing the 3-phase RMS symmetrical bolted fault current and the device characteristics to determine arc duration, there's no other details on performing short circuit and coordination studies as long as that information has been made available. There's also a lack of explanation for data verification as supplied by owner. And I think this gets to the heart of most of what I see as the focus of this new model or this new standard. It does not evaluate the suitability of any installed equipment versus ratings. Normally we refer to this as equipment duty. And there's no mention or discussion of 3-phase arc flash above 15,000 volts, single phase arc flash, and anything in the DC systems. All of that was a little bit of a surprise to me coming off the first part of the exposure. I do want to suggest or advise that there's an expanded bibliography that includes some documents that were not either in existence or in release at the time 1584 was originally developed, but still in the header for this, there's the tagline that references or resources that provide additional information or helpful material but do not need to be understood or used to implement the standard. The reference to these sources is made for informational use only. So that's kind of a heads up that there may be some discussions about these documents in the future and how they apply to any future models. And in clause 4.3, there's a discussion on typical bus gap and enclosure size that suggests that data based on the actual working distance and enclosure size is preferred. The typical gap that's provided in 1584-2002 is based on the lab test setups. And likewise, the actual working distance and conductor gap or enclosure opening are preferred if they're available. And in this standard, they have duplicated a table from the 2018 standard itself. Now this to me was an interesting change. And it's a description of the minimum scope of work because it's a reduction in what was listed in the original 1584.1. And there's an emphasis on the fact that these locations need to be agreed upon by the owner and a qualified person. And they could include, but it doesn't say shall, but which gives some interpretation to this line, but it could include locations where workers may be exposed to arc flash hazards during examination, adjustment, servicing, or maintenance. Now the key here, I think, is the agreed portion, and I believe as we go through this document, this is a theme that's repeated, and it's an agreement before anything gets started as to what's going to happen ultimately, and it's not a one-way conversation, which I think we may have been guilty of early stages, laying down the law, if you will, with these new standards that people were not necessarily familiar with. Then the minimum deliverables is another area of, I don't want to say confusion, but misunderstanding. And some people think, well, no, I just provide the minimum deliverables and my work here is done. What the suggestion in this document, the new updated standard, is the arc flash hazard calculation can include a spreadsheet with the following information: equipment ID, three-phase bolted fault current, arcing current, duration, arc flash boundary, incident energy, and working distance. But then it suggests that we go to Annex B for further information on suggested deliverables to be provided by a qualified person performing the arc flash. Now, if you jump to Annex B, now some of these spreadsheets were available in the 1584.1 2013, but I think the emphasis on the minimum and the way to expand it is what the bottom line here. And that is, as we start the work or before we start the work, we understand who takes ownership of that particular phase or responsibility in deliverables. And so I think there's a reason, and valid, justly so, that we want the owner to know what's involved in the details of the steps that need to be included in a study, and whether or not they have the possibility of avoiding that or negating that or even supplying it themselves is part of this discussion. And so our Annex B goes on to talk about references in Clause 4 and 6. These are references to how the data collection could and should be done based upon the discussion by the owner and the person doing the study. And then again, it takes up the spreadsheet, which was only one page in the 2013 version. Now it takes up a better part of a page and a half. And it concludes that the deliverables may include incident reduction considerations only if it's part of the scope. So again, I think there's a subtle shift there where a lot of studies, the recommendations were a big part and may or may not have been something that was necessarily requested or expected. Again, defining this stuff up front, I think relieves a fair amount of friction between the owner and the person providing the service. Now in Clause 5, there's a description of system modes of operation. This was a fairly detailed description in the 2013 version, and it's been modified in the most recent update to suggest that the simple radial system may only have one mode. There's no discussion of without motors and with motor contribution in this clause, but as you get into more complex systems, there's a reference to what an expanded or complex mode of operation would entail, and the fact that this should be consulted or developed as a scenario during the study. Clause 6, when it's describing required data collection, just indicates that a qualified person performing the arc flash calculations should be required to conduct a study. Now, this was previously a 3-page explanation, and now it refers us to Table A1 and Annex A for details. And again, it's an example. We've already looked at A1. It's an example of how the division of labor or division of responsibilities has been specified or detailed and agreed upon before things get started. So again, the facility owner isn't being caught by surprise with a requirement, and has the potential for developing that knowledge themselves based upon what the overall agreement is between the service provider and the facility owner. And again, A1 is the task matrix and data collection considerations, and it is a very much in-depth, detailed list of what needs to be done. And having this discussion beforehand, I think, helps a facility owner who's contracting out the work to understand why the effort and the hours involved are substantial. And then it dovetails into the owner supplied information and whether or not that's adequate for the purposes of a study. And that's part of the checklist to make sure that we've verified an agreement on both parties with who's doing that function and whether it's adequate to the purpose of the study, the model itself. Then in Clause 7, there's a discussion about bolted fault current and arc duration. And again, it's been condensed down to one paragraph in this clause. Clause 7 describes bolted fault current as one of the inputs to the 1584-2018 model, and it should be available 3-phase RMS symmetrical short circuit current at the bus in question. And then it refers us to Clause 10, Annex B, another more in-depth discussion about the bolted fault current, but it doesn't go into the derivation of it or the way to actually produce it. Likewise, arc duration is described as one input to the 1584-28 model, and it refers us to Annex C for further information. Well, Annex C looks something like this. And it basically says simple systems can use the TCC curves as a sufficient source of information for arc timing. Complex systems may require special consideration for differential relaying or optical sense relaying, and then provides table C1 for breaker opening time, which should be included or added to the response time of the relays. Now again, this is all included in the original 1584.1, but it's significantly reduced in volume. Clause 3 under the Annex C specifically describes overcurrent protection device considerations and describes the need to exclude main breakers. I think this has been left intact, intact from the original discussion, because it is an area where people have misunderstood, I think, the reason for the exclusion. And it describes that only an upstream protective device that is isolated from an enclosure can limit incident energy for that enclosure. And it also adds a note, consult with the manufacturer to confirm if equipment provides isolation between the main breaker compartment and other compartments. As I describe the need to exclude versus include the main breaker in the panel, if you walk up to a panel and take the cover off, and you're going to do work on the main bus or the buses that have been uncovered, if you can look up and see the incoming conductors to the main breaker, then you cannot count on that breaker to protect you from a line side arc if one to be initiated or created. And so that in that case, you would have to exclude the main breaker for that panel for calculating instant energy. And I think this also points to the fact that most 480 volt panels in the United States do not have a barrier between the incoming conductors and the person working on the main bus. Now, with that said, there is an improvement in the National Electrical Code to provide a cover or a barrier over the incoming terminals for a breaker. And the purpose of those, and if you look in manufacturers' catalogs, they end up being a small piece of plastic that form fits over the incoming terminal of the main. And the purpose of those is to prevent incidental or accidental contact with the voltage, which is well intended and a very useful safety device, but it doesn't provide anything in the form of an arc barrier. So keep that in mind as you're looking at new installations, in fact. Then Clause 9 has additional considerations for electrode configurations. And here there's not much change in guidance in how to deal with electrode configurations, other than to refer to 1584 and Annex G, where the discussion is in the standard. So for some equipment, it may be possible to use more than one electrode configuration, which has been a policy that we followed since the release of 1584 2018, where they define the electrode configuration. So there's frankly not much help or definition, new information on that topic. Likewise, enclosure size, it refers us to Annex G of 1584 2018 and suggests that we should use the typical dimensions if the actual dimensions are not available. So not that I'm whining about it, but it's really not an additional explanation of some of the areas that we were struggling with when the model was initially released. And admittedly, the committee indicated that there wasn't going to be much in that form as far as increased information. It was more or less to align with the differences in the standard 1584 versus its predecessor, 1584 2002. Now, in the 2013 version of 1584.1, there was a report, this is in Clause 10, a report that shows, or a paragraph that shows what's considered a minimum amount of deliverables beyond, or as a subset of the Annex D, which we talked about earlier. But then it goes into further discussion about the recommendations that should be made for arc flash incident energy reduction. Now, this was in 2013. These are not listed as such in 2022. In the 22 version, again, it includes in Clause 10 an expanded version of what's suggested as a more complete report consideration, and then include documentation on how the calculations were made, the modes of operations, manufacturer's details on the equipment, and then go back and jump into additional information as agreed upon with the facility owner. So there's nothing at all regarding mitigation. So in summary, the overall technical information or differences that have been highlighted or explained has been relatively limited in this release. What I see as the expanded guidelines in the form of spreadsheets and tables encourage better communication before, during, and after the study. I personally applaud that because that's an area that I think we can recognize better acceptance in the industry, because it gives some flexibility to the cost impact and can be used as a further discussion between clients and service providers for not only developing a proposal, submitting bids, improving involvement of the client's team as the work is being done or the study's being conducted. And it has the potential to reduce the overall cost of completing this study and a better understanding between clients and the service providers. And the one that I really emphasize, I try to emphasize, is how the improved arc flash knowledge of the hands-on employees can be enhanced by this two-way conversation during the overall process. So that's my 2 cents. How it affects you, I'm sure may be different, and I'd appreciate the feedback. So I would suggest that you do get a copy of 1584.1 2020. I can get it's 2022, and it's available under the standards IEEE.org website. So Appreciate your attendance today. I'd be more than happy to hang on for questions, or you're more than welcome to enter questions either in the survey or via email to me personally. Thank you everyone for attending and have a good day.